All right, we can get started. This is the network review of this Congress network. These guys actually did an excellent job in building everything up in only 72 hours, which is quite amazing. And they will give you the insights on this network now. The speakers are Elisa, Niels, Stefan, and Maxim. And Stefan will go ahead and start. Please give an applause.
So, welcome. I see more people than last year here. It must be an interesting session last year, so that many people decided to join us this year. Network 23C3 is not totally different to the things we have done last year. We have some problems with some of the sponsors, so we have to rearrange some of these things, and my part is to present some of the IP uplink questions we have to solve. Later on, as mentioned, we will hear something about the in-house LAN network, we hear something about the wireless LAN, and something about how we get statistics, all these nifty little pictures you can see at the events webpage. Okay, let's start with IP uplink. Was a short introduction. This was a planned network in the beginning. As you can see, there are a lot of abbreviations there. This is all in Berlin. On the left side, upstairs, this is a co-location facility in the Gradestraße 60. Some people know it under a different name. It's called Level 3. On the lower left side, you find AK, meaning Albo-in-Kontor. Lower right side, Lützowstraße. And on the upper right side is the BCC itself. The wire itself, you see the thicker lines are 10 gigabit Ethernet links, the smaller ones are all gigabit. There's not one single 100 megabit link anymore. This was a planned network. One of the new inventions this year was that we use WDM technology, and that we have on all these links dark fiber connectivity, so that we have a chance to use 2 links between every location. One thing you see at the BCC, which was something like this, a phrase called, if you want to get peering, you need beering. It's a common phrase. It was nearly the same thing. I was in a location here in Berlin with one of a guy from Versatel 2 days before the event starts, and says, okay, you want to have bandwidth, we have a fiber into this BCC building, you want to have another gigabit of IP uplink. I said, yes, why not? And we fetched a second router so that we have this year a totally redundant setup. So even if the main fiber would break or anything else you see, G60, AK and LS wouldn't work, we still would have had 1 gigabit of traffic here. Now to the things, what happened really. As you see, there were a problem with the fiber between the Lützowstraße and the Gradestraße 60 and the Albo-in-Kontor, so we couldn't fire up the level 3 uplinks there. We have shifted the connectivity a little bit, the wires a little bit have changed, and I will show a little bit more in detail. The Gradestraße 60 is not as important as we thought. It would be nice to have this because this was a link going with 1 gigabit to Düsseldorf and there to an internet exchange point. To see how many traffic we could push over the network to an internet exchange would be a nice feature, but does not happen. Albo-in-Kontor looks a little bit different. There was everything up and running. We have on the left side the KPN uplinks, KPN Eurorings, going to a switch called Mr. Hartman. This was a Cisco 7600 equipped with 10 gigabit equipment, going to a WDM technology, going then to the Lützowstraße. We put these linked directly to a second 7600, adding some traffic from dehosting, and have there 2 routers. One, the 7600 is called SAM, the second one was Mr. Coatsman. This was a router terminating the cogent uplink. They sponsored us with a gigabit. Putting this traffic on the WDM system means we have put the Mr. Coatsman on 1 wavelength, and the second wavelength we used for the 7600. In the BCC itself, We split up the traffic in A87, this is the basement floor where the Versatile has their equipment, their rack, and installed there another router called Jack. Jack was backup Juniper, or you could say the Versatile uplink with a gigabit. And then we transported all the traffic to the left-hand side to a switch router called Jill. This was a Foundry RX8. This is the part where we go more in detail with the talk from Niels, because he built with his colleagues the internal LAN. Uplinks itself, we got the AS numbers sorted by rising. 174 is cogent, 248 was our own prefix. Then we have 286 KPNU rings, 5430 from Freenet, this was an IPv6 tunnel. 8881 is Versatile. E6 does it, it's gray because it doesn't fire up. Maybe you have it in the next year up and running. And then we have D-Hosting, the local provider in Berlin, who supplies us with IPv6 connectivity to major IPv6 networks in this country, not to mention any names here. Mesh is the level 3 reseller. He has also problems that we did not have problems with the fiber connectivity from level 3. To show some of the things, I think it's a marketing tool at the RIPE. They call it BGP Play. And we have some interesting things there. You can see there's announcements made, and I want to present this for you. And everybody is invited to run it on his own laptop or on his own computer. There you can see how the advertisement of the AS numbers are working. I have to switch. Thank you. So this is a website. We will put the presentation on the website. You can download it, and there you have the link for it. Start BGP Play, it's in Java program. You put in the prefix we used. We got in /16 from RIPE this year. Oh, it's an American keyboard. And let's start with the 22nd of December. 9 o'clock, it's okay until now. The data sources you see down there, this is route, some kind of route collectors. They're transmitting, they're all over the world, and they're collecting the routes announced in BGP worldwide. So now fire this up. So let's start. It looks like a looks like a small movie. I will make a short break here. Where the cursor stands now is 248. This should be our AS number. Is this right? Okay. And yeah, downstairs you see the 286. This is KPNU rings, and all these lines here in between are announcements from our network to the outside world. Between this, and I pulled a little bit out, is A81. This is Versatile. That's our announcements. That's KPN, and I move it a little bit around. You see it's very well connected to a lot of AS numbers. And I think we missed one here. It's Versatile, it's KPN, and where's Cogent? Oh, it's the 22nd. Here it is. Okay, so let's. So you see every time the line starts to move, there's some announcement. At the top you see the date, the route withdrawal, and now you see how the routes are moving between the different uplink providers. Pardon me? This only means that there's an announcement. It only shows that up in the small window at the top you can see the announcement itself. There's a phrase called path change from, then you see numbers, these are the AS numbers, and these are the way a packet would go if it would try to reach us. And as a last number you see always the 248 is our AS number. And then you see a path, 13237 goes over 286 to us. And every time such an announcement was made in the BGP cloud, you will see a thicker line in the presentation. So on the left-hand side, it looks like a histogram. You see these pink lines or pink spots there. This is now the number of announcements you are doing, and I will skip a little bit to show we are now at the 21st of December. It's Christmas Day, and as you see, at this moment we have 881 Versatel up and running, starting to announce our prefixes to the world. Next remarkable point is this. We fire up another, the other providers, Cogent as an example up here, 174. You see there are a lot of announcements going to Cogent, going out. So time steps forward. You can see that the it gets a little bit more complicated. There are much more lines now. But if you start to move the 248, you see that we have 3 uplinks, which are really well connected to the world. Important point here, this means that we have a very good traffic share normally between the different uplink providers. You can see in the statistics. Every uplink provider supplied us with a 1 gigabit port. In average, I can say that we have more than 1 gigabit traffic, so that the traffic moves over different passes, and it was very well balanced. Okay, stop it here. I will go back to the presentation. Everybody is invited to try it himself. It's a free tool, reachable by the internet. Okay. So some remarkable points maybe is that we started at 24th. You have seen the announcement to Versatel at 10 o'clock in the evening. KPN on the 25th. At 9 o'clock, Cogent comes up on 26th. And we have a little problem with the Cogent uplink. We have to prepend the path, meaning making it worse for the routing decision. We have to, there you can see a little shift in the announcements between the different uplinks. It's 2 o'clock in the afternoon, can look after it. Coming to the bandwidth itself, as mentioned before, Cogent gave us a 1 gigabit link, limiting it to 400 megabit. KPN a full-blown gigabit, Versatel full-blown gigabit, and de-hosting gave us 600 Mbit. We have an average over the whole Congress of 1.6 gigabit, that's, and we have incoming traffic of about 0.6 gigabit, meaning average a quarter is coming in, 3 quarters going out. Statistics, this is the statistics from KPN Eurings. This is only from today, with an average of 5 minutes. This is the statistics we have seen the last few days. Going a lot of traffic outside, you can see that the link is nearly at the limit. We have 800 megabits there, pushing traffic over KPN to the world. Not too much traffic, less than 100 megabit coming in from there. Cogent, it's 250 megabit. It's the other way around. We got a lot of we got a lot of traffic from them, but pushing not too much traffic outside. It's normally a sign that the internet connectivity to the network's DSL broadband carriers are not as good as maybe as KPN. Versatel, it's quite balanced, very good balanced. We have spikes up to 600 megabit. And as you can see, if you sum this up, we have more bandwidth to the outside world used than we have on every link available. This is a total graph. No, sorry, forgot to mention is de-hosting. This is also running very well and very balanced traffic. This is a total uplink for 24 hours. You see that we have an average from 1.6 gigabit there, and you can see the line follows the normal at 8 o'clock. There only 0.8 gigabits, but we never drop below 0.7 gigabits. Issues, we have to consider if we use more bandwidth in the future that we need more bandwidth to the single AS so the single IP uplink providers with the AS numbers, because load traffic management and traffic shaping using the BGP protocol is a very complicated task. Therefore, we will try next year to get more bandwidth from the uplink providers. What we have, getting bigger ports here, I mentioned this. Core switch, router switch, this was our endpoint of connectivity. As you have seen, we have a lot of redundancy inside the IP uplink. We have only one single core router. Maybe we should try to get a second one in the future. Core routers offsite, meaning we have a lot of BGP traffic offsite. We have only traffic coming inside. We do not do BGP here in the house. Meaning if we taking down the network, we only have to move all stuff from this building to the suppliers back again this year, and can take down the network in the outside world in 3rd of January, so that we have more time, maybe have party. And the second thing is insurance. It's much cheaper to have these boxes standing outside and not inside. Okay, outlook. Maybe from my side for IP uplink is we have the camp next year, 2007. Maybe it's a new phrase, there's fiber to the curb, but I changed a little bit, fiber to the camp. We should try to get also a fiber connection to the campsite. Maybe a gig or maybe a 10 gigabit link uplink. And the interesting part will be which distribution layer we will install there. But it's not my main focus, it's more the focus of Niels. Maybe you can tell us later on something about it. I think I'm finished now, and we'll hand over.
Sticker campaigns. It takes the form of text that uses original words.
All right. For the next few minutes, I'll be talking about the BCC, the network we built inside the BCC, hardware we deployed. Switches we installed, how much traffic actually ran over it, things we encountered on the way here, and have some pretty graphs at the end to entertain you further. So, from the user point of view, I think for most people the internet connectivity at the BCC looked like this. They connected either via cable or via the wireless network to the internet. This is a simple diagram. As we go down the OC layer, as we descend down the OC layer, it gets slightly more complicated. This is the IP layer. This is not that tricky. We have a couple of VLANs all connected to a central core router that was upstairs on the D level above the circus hall. It had 10 gig outgoing, it had gigabit links outgoing to the outside world, to the internet, via a variety of routers that were discussed by Stefan Wahl a few minutes ago. There were links to various places, either directly or via another set of switches that, of course, are not in the IP layer diagram. So, layer 2, I had to keep scaling down these graphics that Arjen made, for which my large gratitude. This shows how the devices were all connected. We had HP switches that you obviously have seen outside, undoubtedly. We had force 10 switches in closed-off areas. We had E300 switches from force 10 with 10 gig uplinks. We had S50 switches from force 10, which is a 1U pizza box type facility, to service aggregation switches in 2 places. And we had some Cisco switches in various closets around the place. This is too big of a picture. It doesn't fit. This is about 2/3 of it. This drawing has everything in it in the whole building. There's patch panels. There's how many patches go from where to where. There is how many patches go from various places in the building. How many are in use. How many we would like to use. How many various other special interest groups at the Congress would like to use. The only thing missing from here, there's also IP address information in here, which is just outside the screen. Otherwise, this would really be unreadable. The only thing that's missing in here is what interfaces actually connect where. But we would need a really, really big printer to get all that information. If you print it out in a readable format, it's about this big. And yes, we did that. The special interest groups that we serviced at the Congress are co-location. People were invited to bring their own server if they had something to share with the community. We placed this behind the help desk in level A. Freifunk had their own VLAN. I don't think they actually got this running. I tried to take a picture of the fiber they ran to a building across the street, but by then it was already gone, unfortunately. Sputnik, the RFID tagging system. All these devices had their own network, were in a separate VLAN apart from everything else, unreachable from the outside world. And the CBAS fiber and wireless link, part of Freifunk. I give the floor to Elisa.
The co-location area. Some of you might have had servers in there. Behind the help desk in La Ville A, in the hack center, we located a couple of servers, patched them to a 1 gig uplink to the E300 for send switch, and then via the 10 gig E-link upstairs to the core router. It was pretty hot in this room. The POC guys actually measured the temperature. I think it was 30 degrees all the time. This is our server park. Located in level D, we had the kind of a room in level D where we were sitting and configuring the stuff, and the core router was also in level D. And we had to connect this stuff to the core router, but we don't really have enough rack space there, so we just stacked it all together. Yeah. D57, that is next to the server park actually, and all the patches from the core router are going over that patch panel, which is an in-house patch panel. So all the time we relied on the in-house infrastructure, because we had to patch stuff from downstairs to upstairs to the core router over the in-house infrastructure.
So
here.
In this picture, most of the orange and all of the blue cabling is ours. The orange cabling are fibers, the blue is mostly copper.
And the yellow stuff is from the BCC?
Yeah.
Same here. Which is one floor lower. That was in C57, where all the patches, part of the patches for level B and level C end up there. So all the patch HP switches and cables coming out of the walls everywhere on the hallways in B and C are mostly connected over that. Yeah. The power, actually the yellow cables you see in here and the power thingies there are from the RFID crew. They needed some special cabling, and we patched them exactly the ports where the RFID finders were plugged into. So all this stuff is from them.
Those power blocks are converted Sony Ericsson chargers that they bought for 50 cents each or something.
Yeah.
They inject power over a few wires. Bit of a hack.
That is the 410. Below that, that is the same room, huh? Yeah, that's the same room. The HP switches were connected via the 410, and not enough rack space everywhere, so it was just standing there, configured on different VLANs we had on this levels, B and C. That is the E300 standing in the hack center next to the co-location. Actually, this gray cable coming from the left corner, that's the co-location. All the blue cables are patches in the hack center and on level A. Also, the RFID people there again with the power, and mostly blue and yellow cables are ours. So that was the 410 hardware. We had a second one, E300 from 410, which was in the other room on level A, 87. That was connected to the IP uplink. On top of it, the Juniper, Stefan just mentioned how the uplink was working from there on. And next to that is the versatile rack standing in the same room, and on top of that was the fiber device we used to get our 10 gig E, 12 gig E in the end out of the building. The movie.
How can a presentation be complete without blinking lights?
Yes.
It's making noise here, but probably not audible for you, so whatever.
So Niels made that movie, and it's kind of funny because you can play it forwards and backwards, and it looks exactly the same, and you don't even... And even the sound is the same, you don't hear a difference. Is it looping?
Yes, it is.
Okay, so I just... Okay, the heart. The core router on level D, where all the stuff on the pictures before ends up upstairs, coming from this patch panels on the left next to it. The stuff on the right was going to the server park. And this Foundry RX was routing all the things inside here of the building. Inter-VLAN routing and yeah.
Right. So these are all the links that we had in use in the building. 3 times 10 gig SR, which runs over multimode. The whole building is full of multimode with ST connectors. 1 10 gig ER outside, 1000 base SX in C57 mostly, and to link to the wireless, and to link to the Juniper downstairs to the core router upstairs. 1 LX out of the building. About 100,000 base T ports, 2 various HP switches, all connecting to the core routers, and all the servers were connected to 1000 base T. And outside, people were able to plug into, give or take, 3,000 1000 base T ports. We had some issues during this Congress and in the run-up to this Congress.
So the first 10 hardware was... Most of the hardware was supposed to be delivered on the day when before we could start building up the network here. So we started on the 23rd, and the 22nd was the last Friday before Christmas, and we arranged all the things to be delivered on the 22nd. I got a call from Stan on the 22nd in the afternoon. The stuff is still in London. So we had a little issue on the London airport because of the foggy weather there. The plane couldn't leave, and our hardware was still standing in London. So on the next day, Stan was talking to FedEx, who actually delivered the stuff for a couple of times. They really put a lot of effort into that. The guys were actually already on holidays when they did that. So in the end, somehow they arranged it to deliver this thing on Christmas Eve. It ended up somehow in Berlin, and it was delivered in the end to Paris and Frankfurt. I do believe they had to put it on a train or something like that because the plane wasn't leaving from Heathrow Airport. But we got the hardware on time, and without the Stan stuff, we couldn't have done the 10 gig links between all the floors in that building here. The servers also were kind of late because...
The people were late.
Because the people were
They left late.
They left late. They had to work, and they only arrived. They brought the stuff here, but with their own car. So it ended up here in the building on the day before the Congress, which was the 26th. The 26th. So we started installing all the services like DNS and DHCP and everything else pretty much on the evening before the Congress started. But the evening before the Congress started was already, sort of a Congress evening, because a lot of people were already here and using some stuff. So
the line for the tickets, for the cash system was already hundreds of meters long, for example, and quite some tickets were being sold, quite some people already in the building. And the DHCP server was running on a Force 10 switch, because that was the best we had at the time.
I think we changed that on the 27th, on the first Congress day. Actually, we set up all the servers and everything was running on our server farm you saw before.
Dan, you had a question.
Did they actually deliver that at 2:20 in the morning?
Yes, they did. it wasn't easy, but actually they called me that they are not going to deliver it at all, not on Christmas Eve and not on the first Christmas days, 26 and 27, and I have no idea how Forsten convinced FedEx to deliver the stuff on Christmas Eve in the middle of the night somewhere in Berlin. No, it was 2:20 a.m. It ended up in some storing space, and they delivered it, I think, at 7 or 8 in the morning. I wasn't there 8 in the morning in the CCC Berlin on Christmas Eve. Sorry? Okay. But then we had to transport it from there to the building here again, because the BCC was closed on the 24th, which, yeah, it was heavy. Okay. Issues.
Outages and issues and outages. We had a bit of a tough time with our core router, which was a Foundry RX8. It started out with a broken switch fabric module. It had been acting up in Amsterdam a little bit, but for the rest worked fine. Until we started experiencing weird random connectivity problems between hosts connected to the router, to a switch behind this router, and then not being able to do anything. They could ping the default gateway, but they could not actually access the internet. They got the HTTP, but nothing beyond that. We first suspected this was a broken switch fabric module because traffic passing through the switch crosses a switch fabric module, and it had been saying a few weird things during boot up about them. So we powered them down one by one, and one switch fabric module, when we powered it up again, said, "Oh, actually, I did not pass my power on diagnostics." And then took down the complete switch, which kept on logging weird messages continuously, so we had to power cycle it to get it back into something working order. There was a lot of broadcast traffic going on, a lot of station movements, and this leads to high CPU load on the line cards. Also, combined with the third issue we had, the line cards ran out of IPv4 next hop memory space. I'll get into more detail about that later. These three are all related. So this is the switch fabric module power on procedure. As you can see, it powers on the SNM, and immediately traffic just stops flowing. There were a lot more syslog messages about internal stuff breaking. First one was about a IPv6 BGP session, and all the rest died. All the OSPF neighbors disappeared because apparently it did try to pass traffic over this switch fabric module, which of course wasn't forwarding it because it said it didn't pass its own post. Line card utilization, this was pretty low. This is taken this afternoon, but during the second day especially, we ran easily with 99% CPU load on the top two line cards. The first two line cards helped the 10 gig links downstairs and to other big areas. So they had lots of ARP, lots of next hop entries to resolve, and this was caused by a design feature of this particular switch. It has a command where you can increase the ARP table to 64K entries. We noticed on the first day that we had forgotten to do that, and the default was at 8K entries, which we quickly ran out of. So we raised it to 32K entries, which is the maximum you can get with the /17 of IP addresses we had actually allocated to various places. And rebooted the switch, thinking, okay, now we're all set. Now we can sit back and have a beer and hang out. So not long after that, the switch syslogged the message printed in red below. And it says info, but what it actually means is help, help, panic, at the very least. So we ignored that for a while, thinking, well, it says info and next hop entries. Maybe it can create some more. So it started saying this, and then we started looking at the switch fabric module that was broken, and we thought, well, okay, if we yank that out, and maybe then it helps. Help these weird connectivity problems that had been starting around the same time. Not knowing how to check for next hop entries, and we looked extensively at documentation provided by the vendor, and We couldn't find anything about next hop entries anywhere except in a cut and paste from a configuration example where the command usage for something was shown but not explained at all. So no help whatsoever, in short. We do have a gold support contract on this machine, however. So we opened the case. It says priority 3, but that was the final priority once it was clear that it really wasn't going to work anymore. So we opened the case asking, well, we get this message, and we also get a lot of connectivity problems. Are these two interrelated? So I was on the phone for quite a while with support. They looked at the switch, they typed a whole bunch of commands. I heard busy typing all the time. They conferred with engineering, and they came back. Pardon. They came back with the message that this particular model indeed supports 4096 next hops. And an ARP entry takes up at least one slot in this table. And well, with the ARP spawns running, we had about 25,000 entries in the ARP table, which happily overflowed this 4K next hop table. So a lot of people could ping their default gateway because that goes to the CPU level, then the CPU sends it down to the line card and that just pushes it out, but traffic through the switch needs an entry in this next hop table. Traffic being routed in hardware needs an entry in this next hop table, so it just didn't work. So a lot of people on the second day of Congress, quite some people had issues that they could ping the default gateway, they got the DHCP address, but they couldn't ping anything besides that. This happens sporadically for people. I'm not quite sure how many people actually suffered from that. I see a few hands. I see all of the hands. All right!
Okay.
At one time or another. Well, after we found out this, we disabled the ARP sponge, we cleared the ARP table, and since then we have not seen the message since, and since then also the help desk has been eerily quiet about network issues. So yeah, we had this bug closed, and we will, however, still take this up with the vendor because it's not really nice that it's a 4K next hops is for an event as this is not enough, because we have 30,000 IP addresses handed out assigned to various subnets, and it means that that we're limited with this particular piece of hardware if we use the network design we used here to about 4,000 concurrent users. Right, so this was the interesting part. This is a connection to a line card in this switch, which of course is not documented, is not recommended, unless under guidance of a tech engineer. And it clearly shows that Houston indeed has a problem. After we killed the ARP sponge, that is a piece of software that answers for ARP queries that go unanswered, therefore reducing the level of broadcasts on all networks. After killing that and deciding to basically live with the high broadcast levels, you see that this freed up quite some next hops in this particular bit of memory. That was, by the way, unsizable in any way. Yes. Graphs.
Graphs, more graphs.
To you.
Yes, some of you might have seen that already earlier today, but I thought while talking about the core traffic, we should show that again. That is the whole traffic going over the core router, the Foundry box. And it's quite more than the IP upstream Stefan already showed, because a lot of traffic was only inside the building and inter VLAN routing, and it was only going from different subnets or different levels inside this building. So we got up to 5.5 gig traffic on this core router. IPv6 traffic inside this building during the last day was also up to 200 megabit, which is, like I said in a presentation before, that's almost the same amount of IPv6 traffic that the M6 Internet Exchange in Amsterdam is doing in IPv6. So we have some IPv6 power users here, I guess, of people not turning off their IPv6 on Apple PowerBooks. What is that? Total?
A85.
A85, exactly. That is the traffic coming from the 410 located in level A, where the co-location was and all the hack center HP switches connected to, and going upstairs to the core router, which was quite a lot. And started out on Wednesday with the, when did we finish the build-up?
Wednesday morning.
Wednesday morning, so Wednesday afternoon, all the people start.
Well, Wednesday morning, the servers arrived.
I patched level A on Wednesday afternoon, I think, so that's why it started exactly there, too. The upstream going to...
The same number that Stefan last
Same number, exactly like before.
This graph is monitored from the inside and not from the outside.
The other one, yeah.
So, different measuring point.
Our statistics, yeah. More? The total traffic over the last day, starting on Wednesday. Of course, more outgoing than incoming traffic, but yeah. Well.
Clearly, some outages visible.
The peak, the drop you see over here. That is exactly when we experienced the RX problems with the core router, and we had to reboot the machine a couple of times during this day. I don't know, 2-3 times in the end.
3 times, I think.
3 times in the end, within like 3 hours or something like that, and that caused a dip in this graph. But after that, it seemed to work quite well again. We had a lot of traffic going on. Percentage of V4 and V6 traffic on the network already seen in the SLO talk before. 6.6? Is that the same graph as before?
Yeah. This is the percentage graph.
Yeah, I think so. Okay. And Maxim. Now more about the wireless.
So I will now speak about actually what we did to make the wireless network work and what we do for preparation and what we done last year. So first of all, a short agenda. I do a recall from last year and then preparation and design. What actually we done before the event started. 1 month before we started to organize the stuff, and today I can say we have finished in about 3 days of setup. So then later about the topology, performance and security, and monitoring for our station troubleshooting. At the end, statistics and the outlook for next year. So what was last year? We had 36 access points, single mode, ABG. It was located all over the building. We had no special focus on lecture rooms or rings or the hack center, where the most people were located. But therefore, we had only 4 access point and 5 gigahertz mode and a very low coverage for that. The Uber switch we used last year supported maximum 512 users at the same time. We used 509. Average was 350. So we run very on top of the box. We experienced high performance issues because we had stations where more than 150 people were located, and they all were using B or G. So it means you have only less than one megabit actually per user. Performance issue came from ARP spoofing, and performance issues came also from people were making denial of service attacks and so on. It's the normal stuff. Of course, last year were the numbers of rogue access points also quite high. I think about 50 or 60 access points. So what we do changed that year. For planning the whole building, we used AutoCAD this year. We not used any proprietary software, so we just used AutoCAD to see how far the locations between the most concentrated points on the event actually itself are. And we looked how are the walls, windows, and so on, the stuff which can do a lot of interferences and reflections. So we make the focus that year on the lecture rooms. Actually, if you're in the building and you're in the ring or something, you can just pull a cable and start to downloading. There's always a switch near behind and you have always parts left. So it was important that the wireless was working in the lecture rooms. For a better performance, we just decided that year to make a better separation of the networks. So this means basically that we structured the networks in VLANs for every SSID here is broadcasted. So we done a separation between 802.11a and b, and also the fixed IP networks. So that are specific VLANs, but on all VLANs are quality of service rules deployed. So quality of service for us means you have at least DHCP, then you got SSH and HTTP, and the stuff for reading mail, POP3 and IMAP. So we does that, and we focused also on peer-to-peer users. So what we're going to do with them, always are people complaining about peer-to-peer users which using BitTorrent, eDonkey, MLDonkey, and so on. And we decided to use therefore a new technique. We deployed a snort box, and this snort box is actually not doing any kind of security or whatever, IDS, IPS. It's doing actually only a monitoring, pattern matching against eDonkey and BitTorrent stuff. So we deployed the snort box in a separate VLAN and monitored the whole wireless LAN traffic inside of that VLAN. So the snort box were getting an encapsulated GRE tunnel for the whole traffic and all uplink VLANs. Performance without of security is nothing. Today we are seeing that many people are publishing stuff for driver exploitation. This stuff is not new. Drivers have since many years bugs, and especially drivers which are working with dynamic protocols. And if you have a protocol like 802.11, trust me, it's not possible to get very stable or just secure, because the protocol itself makes it not possible. It's a non-authenticated layer 2 protocol. How you want to secure something like that? So we done for preparation fuzzing of all necessary services on the controller. For us means we done fuzzing on services like ESA, KMP, IPsec, but also on the 802.11 layer. And that helped us to see if there are problems. We found nothing. Especially we found nothing on 802.11. But on IPsec we decided that we're not providing the service because the CPU load was too high. So to look what is coming with CPU load, what the CPU load will be if many users on it, we do a load test with iPerf. And yeah, at the end, without filtering an access list, you're nothing. So that is also important, especially on your uplink ports and your management ports. So this is actually the topology of the whole network. It's a layer 2 backbone where connected the Aruba 800 distribution switches over GigE uplinks and trunks for access point management and switch management. Access point management means the controller is only forwarding packets, and the access points are only dump access points which are creating a GRE tunnel from the access point interface for wireless to the controller. The access point is not just a bridge, it's transporting the traffic like is it with the radio tab header, with all the 802.11 element IDs to the controller, then de-encapsulate it and process it. For uplink VLANs, like I told you, we used 3 VLANs, and the snort is also collected directly, gets the traffic over GRE. The access points this year were AP60, AP70, dual mode access point, so we had complete coverage on ABG. And that's how it looked like in the air. To get it actually look like that, you have to calibrate it once. I will describe what calibration means, but we had interferences because there are more than 200 people using it, and if you cannot limit the transmit power of a client, you cannot do anything about it. So if you calibrated your system, if you have lowered down the transmit power of your system, there are always clients who have cards with 100 milliwatt of transmit power, and you can do nothing about that. So what does calibration mean? Calibration means all access points are shut down and working in monitor mode for just the time where the calibration is finished. Monitor mode means you're monitoring the 802.11 layer, so the wireless link layer, and it does one station in access point mode. So it sends frames, hello, I'm here, and all other stations looking for the beacon frames from the station who's sending. Every station which these beacon frames will receive will lower down the transmit power so long there are no stations are seen anymore. This first station, which is broadcasting actually. So this is done with 34 access points. It takes about 20 minutes, and then it's finished. We're doing load balancing because most of the rooms had 200, 300 people sitting in one access point. And therefore, we just set a maximum limit on 60 users per access point. So if one access point is full, the users go to the next. The Aruba station is sending a de-authentication package, so it disconnects the user. If the user comes again, it reconnects him. This is only done if the station is not finding any other access point which is better than that one which is already full. And again, traffic shaping is done on that limit also. What we done about security? On 802.11 you have a lot of things to do, and basically it starts with layer 2 frame monitoring, like I described it. 802.11 is an authenticated management protocol, and the frames are completely spoofable. You can do whatever you want. And we wanted also to see what is coming on us on this event. On DEF CON and other events were things published with driver exploitation stuff. And we were looking after the attacks were here actually starting. We found one interesting attack. So people are sending de-authentication packages, spoof de-authentication packages to us to broadcast address, so to every user. And inside of the de-authentication package you have a 2-byte field for a reason code. This reason code actually means I've disconnected you because your key was wrong, or because you're sending wrong capabilities. You cannot join me because you're not an 802.11g user, only a B user. And this means 2 bytes, 65K of possibilities, and he counted that high. And most of the notebooks which are running Centrino Windows are crashing at that moment. We're doing the same, but we're doing it for protection. We're protecting our users to join rogue access points. So we don't want that you're joining a fake access point and all your SSH fingerprints are other, and people are doing man-in-the-middle stuff. And we're of course doing gateway protection, because if someone takes the MAC address of your default gateway and does upspoofing, whatever, so we blacklist his MAC address and he will be kicked out. So monitoring for troubleshooting. I need a web browser for that. If you have more than 1,000 clients in your network, you want to see what's actually going on, how many people are getting IP addresses, how long they stay in, how long they're at one station. And that is necessary for debugging purpose. The whole stuff is anonymized, and we're seeing here one graph. We recorded it 2 days ago on the 28th, and we coded it in Ruby and of course light HTTPD we used as a web server. Okay, I have to be faster. Okay, let's come to statistics. We have 1,678 associations peak and an average user count of 631. We had problems with the RX8, so we had to change our uplink ports from one slot to the other. And of course, MRTG sucks, sorry, but the counters are not 100% clear and correct. But it's an average peak of 30 minutes. At the first to second day, 1,678. Third to fourth day, 1,423. And maximum inbound traffic on 156 megabits on the first 2 days. So what is the outlook for next year? Maybe protect our users, block interstation communication, buzz. But I don't think it will help. People can always inject packets, and a bridge filter is nothing against that. Provide 5 gigahertz cards. On the 2.4 gigahertz layer, you have no chance to make on such an event the wireless working. So if you have the possibility that buy your 1100 2.11a card, use 5 gigahertz, and you will see that you get more performance out of it. Okay, so use 5 gigahertz. I want to thank especially Cookie, Hartmut Schröder, David, and Stefan. Thank you.
One more.
This one. Okay. I also would really like to thank the NOC help desk. The guys and girls sitting at the help desk were helping out the whole time, users, and giving us in the end the possibility to work on the network while trying to keep the users calm when something was wrong. So thank you very much.